Hello everybody. I owe an apology to anybody in the audience who's from an antivirus company, and I know you're not any longer. A definition, a busted flush, anything which ends up worthless despite having shown great potential. And I think that's what traditional antivirus is at the moment. Something that was probably very good once upon a time and now isn't so good. So apologies to anybody who is offended by it, but you know, I haven't had my refund from the charm school yet. So a bit of background about me first of all. I did a computer science degree in the early 80s. Yes, that was before PCs. Computers were very much more secure in the 80s because they were mainframes and minis that sat in great big computer halls and were guarded by white-coated lab technicians who didn't allow you to go anywhere near them. Also, there was the small matter of having to program them using Hollerith cards. And now, this was in the early 80s, before the Computer Misuse Act, of course, so I can actually tell you, yes, I did learn how to hack. So in that period, it proved very useful because I joined the legitimate security field in 1986, and I joined a company which set up the first evaluation facility in the UK, and I helped them to do things like write the UK evaluation methodology and learned how to hack for the government, which was interesting. So I was a security evaluator, did pen testing and things like that. I was then a proper consultant, security consultant principally, but various other things, management consultant and so on. I had various management positions in that company, and then eventually I decided I'd go and do it for myself, and I formed a security and safety company called Echelon, not the Echelon you heard about earlier, which is the spy network. I sold it in 2006 to a multinational, and one thing and another, I ended up managing to have a complete year off where I couldn't work for anybody. So I came to Royal Holloway in 2007 and did my master's in information security, which is great. One of the best times I've ever had in my life, I would say, and still am enjoying it. When I graduated, well, before I graduated, I actually finished the course in 2008 and then decided that I was going to go and do something I hadn't done before. So decided to go and work in the Big Four. I actually went to work as a director in KPMG and ran their security practice for the public sector. And guess what? I'm not a big company person, so decided that maybe I'd be better off not working there any longer. So after a couple of years, I left and joined William Rothwell, who's sitting down here, who has established a company called Abatis. And as you see, this talk is all about malware and where Abatis fits into the grand scheme of things. So I'm going to try and justify my claim that traditional signature-based anti-malware is a busted flush. To do that, I am going to take you through what malware is, how it works, how traditional antivirus works, and an alternative approach that works. And surprisingly enough, the alternative approach is what Abatis produces. So, what is malware? Well, it could be a virus, a worm, Trojan horse, keylogger, all those sorts of things. But so malware is shorthand for all of that. But more esoterically, I suppose, malware is a value judgment. It's anything that you don't want to see running on your computer. The point being, it has to run, it has to be an executable, because it has to execute in order to do something bad on your computer. So, malware has become very big business. Cyber criminals, cyber terrorists, hostile state actors, APTs, advanced persistent threats. I always laugh when I see that. Advanced, that means it beat your antivirus. Persistent, it continues to beat your antivirus. And definitely a threat. You remember Stuxnet, that lay undiscovered for a year or more before doing some serious damage to the Natanz nuclear facility in Iran. So, malware, it can allow the bad guys to steal money, intellectual property. They could steal your identity and then do something else with it. It could allow them to steal state secrets, bring down nuclear facilities, all sorts of things. Damage the critical national infrastructure. What we're finding is that's one of the biggest threats now. And it's a serious threat. And I think Obama recently issued some notice that he was seriously worried about the damage that things like Stuxnet could do to the critical national infrastructure in the States. Have I convinced you yet that traditional AVs are busted flush? Not yet. Not yet. Okay. So let's have a look at how malware works. I'm going to take a worm as an example. So the first part of the worm is the warhead. That gains access to the victim's machine. The second part, the propagation engine, actually transfers the malware into the body of the victim. Target selection, it looks for things of interest on your machine, whether it's your credit card details or whatever. The scanning engine scans across the network, so your machine's connected to other machines through the network. It looks for other things to try and infect. And then finally, the payload is the nastiness, the lump that's going to do the damage to you. So if we could take control of the propagation part, if we could stop that propagation, we kill the rest of it. And really, that's what we ought to be trying to do. So stop the propagation phase, kill all the subsequent phases, okay? How serious a problem is it? A pernicious problem. Even on mobile devices and Macs now, all the things that you thought were once safe aren't. So you need to proactively protect against these threats. The problem with traditional AV is it's reactive. Somebody has to become infected to allow that virus signature to be created by the anti-malware companies and then distributed to everybody that has their product. This problem is going to get worse. Smartphone use is rocketing. There are 4 billion mobiles in the world. Over 60% of the world's population has one. And in the developing countries, these people are using their mobile phones, their smartphones, to do internet commerce type things. They've completely bypassed the traditional desktop and the laptop. They've gone straight to using these mobiles, cheaper, more portable devices. And yet there isn't a very good way of defending those mobile devices. Yes, the antivirus companies produce a variety of good configuration guides or cut down versions of their product, but really pumping megabytes, gigabytes, who knows, of signatures around the place over the network is just not going to work, not sensible. I've got a pop quiz for you. What is the connection between the Hoover Dam and the Natanz nuclear facility in Iran? Yes, Amanda.
The control mechanism by any chance on the thing?
Good idea. Probably yes in both cases. But the one I was really looking for, because I hadn't thought of those two, is neither of them, apparently, was connected to the internet. The reason I bring this up is I was at a presentation by somebody who said, I'm forever fed up. In fact, he was in charge of security for the Hoover Dam. And I think one of Obama's aides kept quizzing him, saying, what are you doing about things like Stuxnet? How are you going to stop half of Nevada being flooded? And his answer was, can't happen. We're not connected to the internet. Completely ignoring the fact that neither was Natanz. You don't need to be connected to the internet. USB keys, for instance, can do the damage just as easily. So there's a huge misunderstanding as well about how malware propagates. Another thing that's causing a problem is consumerization of IT, people using their own personal computers to access the corporate servers. And how much effort do you put into protecting your laptop? You probably take an awful lot of effort to protect yours, but the average person probably doesn't do very much at all. Spam, phishing, farming, I assume you all know what these terms mean, and spear phishing in particular, actually going after a very specific person, writing malware to target an individual, a high net worth individual usually, somebody that runs a corporate environment, for instance. Some staggering statistics. McAfee identified 150,000 malware samples every day in 2011 so far. Almost one every half second, and a 60% increase over 2010. 19,000 new malicious URLs every day. And this is the worrying thing, 80% of those were legitimate sites. So, hang on, legitimate sites, that's a real corporate company who would employ antivirus. So almost every legitimate company uses antivirus. 99.999% recurring of companies use AV. And yet, it isn't stopping 19,000 new malicious URLs every day being discovered on these sites, legitimate sites. So, even if you are using traditional antivirus, you're still being hit. Busted flush, anyone yet? No? All right, so what does the industry say about itself? Can you all read that? Or do I have to? Back in the 80s, computer experts were quick to dismiss PC viruses as harmless. We need to learn from the mistake and start taking the mobile malware threat seriously. Only by taking preemptive measures can we equip ourselves against this pernicious and escalating menace. It was Davey Winder, security journalist and consultant. In 2007, there were about 200 malware threats for mobile phones and more than 250,000 viruses for Windows. And that was Graham Cluley, senior technology consultant at Sophos, 2007, remember? Symantec, in 2010, their report said 286 million pieces of new malware. I love this one. John Vigouroux, if that's how you pronounce his name, of M86 Security. The security industry has done a miserable job of protecting customers and industry. More than half of malware is not blocked by antivirus, as vendors can only deal with known malware. You have to have an infection to create a signature to try and fight the infection. The approach taken by most antivirus vendors is not good enough, as most claim to block 99% of known malware, but most cyber criminals use unknown variants. Another quote about mobile malware on the increase. The prize for the most obvious statement is, according to Ken Silver, CTO of VeriSign, criminals will go where the money is. Duh. Silver told CNET News, if you start doing things of financial interest with your mobile phone, they will find a way to get your money. Really. And I love this one. A couple of days ago, yesterday. Antivirus technology can't stop targeted attacks. Antivirus is dead because it's unable to detect attacks properly and is incapable of working on mobile devices. Nir Zook, founder and CTO of Palo Alto Networks, to SC Magazine yesterday. So, the staggering statistics to back up my claim that traditional AV is dead. This table shows, it's now a year out of date. There will be a new one out before long, I hope, and I don't expect it to have improved much, in fact, probably a lot worse. But it shows for the popular AV companies how effective they are at stopping malware. So, big threat is zero-day attacks. So on day one, how many do they stop? If we highlight that particular line there. Symantec catches 21%. Something called Dr. Web catches 7%. Kaspersky 22%. Okay. Look then down to day 30 and you find Symantec has crept up to 47%. Kaspersky's at 92%. Sophos at 85%. The point being, on day one, less than 19% of malware is caught by these popular packages. And the detection rate increases to nearly 62% on average after 30 days. So if you have one of these packages, you're almost certainly going to suffer an attack which is going to work. How do they do it? The most popular one at the moment is drive-by downloads. You just have to go and visit one of these infected websites. Just by visiting the website, you become infected. Another great one is fake security tools. Sometimes they're given away for free. You've got X pieces of malware on your machine, it says, and now they actually say, and you can buy the tool for $5. So they're actually getting you to pay to put malware on your machine. Fantastic. And social engineering, things like Facebook, constant source of problems, malicious links in email, and so on. So if traditional signature-based antivirus is dead, what can we do instead? Isolation. Is anything isolated these days? We used to talk about air gaps. You just don't have them anymore. You have USB keys that you can stick into machines. Wi-Fi, Bluetooth. I love this one. Avoid questionable sites. How do you know what a questionable site is? Download software only from reputable sites. Run antivirus on any downloaded material. Well, as we saw from one of the earlier slides, 19,000 piece of malware discovered every day. 19,000 websites infected every day being discovered. 80% of them legitimate. So Microsoft.com could have some nastiness on it. The worst ones are actually things like news sites and social networking sites. Anything that says, you know, would you like to see a picture of Pippa Middleton's bottom? It gets lots and lots of visits, so that's the best place to stick your malware. Anything that's going to attract high volume of people.
Sorry, is that malware on the website, or is that actually just a redirect?
It could be either. It could be either. Yeah. Signature-based, well, that's what we're saying is the busted flush, 19% effective, so don't think it's that. Heuristic. Well, actually, the current crop of anti-malware tools uses heuristics to try and do that fuzzy pattern matching in order to find something similar to the signature files that it's got. Reputation-based, a lot of effort being put into this by the traditional AV companies, but it relies on hashing, and hashing can now easily be defeated by various tools, as William will demonstrate if you ask him nicely. Hashing can be defeated. Blacklisting. Seriously? Could you list everything you don't want to see on your computer? No. Whitelisting, perhaps? Now, that's really attractive in principle, but the problem is, to do whitelisting, again, you have to hash the applications that you are happy to see on your machine. Every time those applications change, you change the hash, and you have to roll those hashes out across your entire estate. So it's an enormous maintenance burden, and large corporates hate it because it is such a huge maintenance burden. Do all these things in combination? Well, that's what the best antivirus tools do now. They use all of these things in one way or another, and as you saw from the statistics in that table I gave you, they still aren't achieving the sort of level of protection that you and I want. So here's the alternative, the real alternative. Kernel level control over the input-output. So malware fundamentally is an executable piece of code. So if you can recognize it hitting your machine and use the ring-based control mechanisms within the operating system, you can reliably stop it getting onto your machine. You can stop it being written to your hard disk. That makes it A, reliable, B, proactive. It doesn't infect you. And as you'll no doubt be surprised to find, HDF is the tool that we produce and does exactly that. It stands for Hard Disk Firewall. So I'm going to give you a quick demo of how it works. Well, not a demo, a graphic. So you've got some malware, the black bug, and a Word document. Could have come from anywhere. It's sitting out there in user mode ring 3 in the operating system, and we're going to try and write it to the hard disk. So without HDF protection, it just goes straight through. It gets written to the hard disk. With HDF protection, HDF creates a filter. It looks to find pieces of malware and knows how to stop them. So the nastiness doesn't get through, it gets blocked, and the Word document does get written to the hard disk. So HDF actually comes in a variety of forms. There is a workstation version, a server version, we have a Red Hat Linux version. It works on everything from Windows NT to the latest 64-bit versions of Windows. We're looking at putting it onto mobile platforms because of this enormous increased threat that we're seeing. And some organizations are already looking at it for use in SCADA environments. That's supervisory control and data acquisition. These are environments that control process control type environments, whether they be chemical plants, pharmaceutical organizations, railways, things of that sort. And traditionally, you haven't been able to put old-fashioned antivirus software onto those because it interferes in timing terms with signals being sent from the control system to the actual PLC, the programmable logic controller. HDF is so small, 30 kilobytes, 60 kilobytes in a server version, and it operates inside the kernel, so it operates at kernel speed, so it doesn't actually have a performance impact. It can be put onto SCADA systems and real-time systems, and that's a real jump forward for technology. And it enforces system integrity. It controls all the input-output to the hard disk. The way that it works, because it doesn't look for signatures, it can stop zero-day attacks. It doesn't need to have seen the attack in the past. It just needs to know that this is an executable. This is something that's going to do damage to the machine, so it stops it before it happens. Doesn't require signature updates. Fantastic. So it really is a fit and forget solution if you want it to be. If you have a laptop and you want to clamp it down, you put whatever software you want on your laptop, then you put HDF on the top of it, and that's it. You don't need to update you don't need to do patching of your operating system. You don't need to do patching of anything on your machine. You don't need to put any signatures on there because it doesn't have a traditional AV signature piece of software. You identify what you want to run, and then by default every other type of executable is blocked. There is a configuration file, so you can identify what you want to see on your machine. You can identify certain things to automatically be updated if you want to. And all that's in the configuration of the tool. Even though we started off saying that this was something that was an anti-malware device, well, actually we started off by saying it was controlling the input-output, so it was good for system integrity. And that sort of morphed into, well, that means it stops malware. But it does a whole load of other things, because if you put it onto a clean machine with just the things on it that you want to be on it, then you've suddenly clamped your machine down. Now, there's an awful lot of instances where people take laptops out of the corporate environment on the road, salespeople, for instance, and they're forever becoming infected. Well, you just create a standard build of the laptop you want to give to your salespeople, put HDF on the top of it, give it to them, away they go. They just will not be infected. Fantastic. So when they come back into the corporate environment, they're not then reinfecting your servers. So mobile workers, great. Keyloggers is something else that we can stop. We can control people inserting USB keys. You can stick the USB key in, but it won't do anything if you've defined that as something you don't want to happen. I've already said drive-by downloads to infected websites can be stopped. The secure mobile platforms over here is something that we're investigating and hoping to get some research funds to actually build those. Critical system protection. We already have clients who rely on us to stop website defacement. I'll give you one example. I shan't name them because this is being videoed, but one client in particular has got a Windows 2003 server box, literally straight out of the box, with no other software on there at all apart from HDF, and that was in place in 2008, I think it was. And they haven't patched it, they haven't done anything to it, no service packs, nothing. And it hasn't been hit. Whereas previously, with lots of traditional antivirus on there, they were being infected all the time because they were running a very attractive website for an organization. The perfect scenario for us is that you have a well-defined machine, that you know everything that you're going to want to run on it. You put clean copies of that software on that machine, and then you put HDF on the top as a layer, and then you're secure. The world isn't like that, so we do actually provide facilities for trusted people to, we call it open the door, and allow new applications to be written to the hard disk, and then you close the door up behind you. So there are facilities to allow trusted people, and trust, as we heard about this morning, you define who you want to be a trusted person. In large corporates, for instance, you'd let your IT department perhaps do that. You wouldn't allow the ordinary user to do it. And the automation of the opening of the door, downloading and then closing the door up, that can all be automated. You'd be surprised how many people don't know what goes on their servers and workstations. HDF does very, very good detailed logging of everything that's being written to the hard disk. You can put it into different modes. So if you put it into an audit mode, for instance, or a learn mode, it'll record what it would otherwise have blocked, but it doesn't then block it. So traditionally what we would say is put HDF onto your machines, put it into learn mode, run it for, I don't know, a few days, a week, however long you think is required to have cycled through all of the things that are going on in your box, and then look at the log file that's created. And you can go through the log file, and it actually identifies all the processes that have written something to your hard disk. So if you are happy with those processes, you can actually identify them as allowed. And you can very easily move them into that allowed set. And once you've done that, you can turn HDF on, and it won't stop those processes being written. But it really is up to you to make sure that you know what you're doing. So you've got to know what you're doing. Secure real-time systems down the bottom there. We are thinking that we could put this into embedded systems. I mean, who knows? Missiles, things that really do have to work properly. I've already talked about critical national infrastructure and SCADA systems. Performance improvement, this really came as a shock to us. We've experimented where we've had laptops with traditional AV on them and then taken the AV off and put just HDF on. And what we found is with one particular antivirus product, which I'm not going to name because that would be unfair, we got a 30% performance improvement just by having HDF on there. And what that means, if you run 30% faster, you could potentially run shorter and do the same amount of work. That could lead, therefore, to a battery life improvement. And I've asked some of the professors here at Royal Holloway to tell me what it could equate to. And they say anything up to a 40% performance improvement, other things being equal. Now that, for the purposes of carrying kit in Afghanistan or whatever, our soldiers have to carry 50 to 70 kilos on their back. If you can reduce the amount of batteries that they have to carry, that's really very serious. So we're actually looking at doing some research into proving that case, and maybe this could become a life-saving measure, in fact. And if you use HDF with a traditional antivirus product, because it doesn't fight with it, it's not like having McAfee and Symantec and they all try and grab resource and fight. HDF just sits there. It controls the input-output. It doesn't worry that there's another package there. That's great. You could run both together. If you're a corporate and you've already invested in Symantec or Sophos or whoever, you probably don't want to throw it away. So great, put HDF on, run it with your product, see what happens. You'll see that HDF is stopping everything. It's finding things that the other product isn't finding. And after a period of time, you can decide to not renew the license for that AV product. And finally, the protection of legacy equipment, as I said, we go back to Windows NT. Everything from NT upwards, we can protect. So there's an awful lot of legacy equipment out there. I was talking to somebody only the other day, and he's got thousands of servers that are running Windows NT, and he desperately wants to protect them, but he can't. Well, now he can, and it means, particularly if he gets a 30% performance improvement as well, he doesn't have to worry about replacing that kit for potentially years. So that really is a huge saving to his organization. If anybody's not convinced that traditional AV is a dead duck, then I failed. You can talk to him and he'll beat you up or convince you. That's it really. Any questions?